Hello, I'm Iftikhar Ahmed and I'm from software engineering. I'm in my fourth semester and my metric number is A20EC3016.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Musab Muntathir Al-Tayyib. I'm a software engineering student in the fourth semester. And my metric number is A20EC4077.
Hello, my name is Lokriki. I am a student of bioinformatics and I'm currently in my third semester and my metric number is A20ET0329.
Hello, my name is Muhammad Abu Talha Ibn Riyaj Hassan. I'm a student of software engineering in my fourth semester. My metric number is A20EC3022 and this is the project presentation video for the operating system course.
For our project, the topic that we chose was non-preemptive priority scheduling and also shortest job first scheduling algorithm. We decided to use this algorithm to make two real-life programs that can be used in real life by real users. We made an emergency room management system using the non-preemptive priority scheduling. We also made a copy order management system and we used non-preemptive shortest job first algorithm in it. Now, we will show how we implemented these scheduling algorithms to construct these programs.
This is the program code for the emergency room management system. So this program was made in the C++ programming language. We have used object-oriented programming and we have used elements of procedural programming as well. So here is a class, the patient class. In the patient class there are private data members and public methods. The private data members of each patient is the name of the patient, the level of injury of the patient, the age of the patient and the issue of the patient. Here in the method section we have the default constructor, we have another constructor, we have the getters and the setters. The getters are responsible for getting the name, level of injury, age and issue of the patient, and the setters are responsible for setting the name, level of injury, age and the issue of the patient. In the main class we have the menu function which will show the user the menu. Basically this menu will be visible to the receptionist of the emergency room. We have a bubble sort function which is responsible for scheduling the patients. We can say that this function is responsible for scheduling the processes. Here the processes are the patients represent the processes. So in priority scheduling, in non-preemptive priority scheduling, the processes with a lower number of priority will get CPU allocation first. So we have applied that here. Basically the patients with a lower number of level of injury will see the doctors first because they have a higher priority, and the patients with a higher level of injury will see the doctors later. Basically they will be at the end of the queue if they have a higher level of injury. In the main function we first show the menu, then we ask for an operation. The operation can be 1, 2, 3 or 4, and basically these are the options 1, 2, 3 or 4. If the patient enters 1, if the user, which is the receptionist, enters 1, then the number of patients will be taken, and so on. Then we have a while loop which takes each of the patient's name, age and issue, and then determines the level of injury. So level of injury is determined based on several things, just like priority in non-preemptive priority scheduling. In non-preemptive priority scheduling, the priority gets determined by size, the CPU usage, etc., etc. Here in this program, the level of injury gets determined by age and by the issue. After that, the data is entered into the waiting list. Then if the choice is 3, if the choice of the user is 3, which means here view the waiting list, then we display the data and the data is basically the patient's name, patient's age, patient's issue, and patient's level of injury. Here the waiting list will be scheduled according to the patient's level of injury. That's it for the code explanation for program 1. Now we will show you the program, how the program takes the input and shows the output for program 1.
So here we have the emergency room management system, and yeah, as we can see, there is like 4 lists, which is including the insert the number of patients that you want to in the waiting list, and insert the details of the patient, and view the waiting list, and also last but not least, exit the system. So in here, I'm going to go through so this is the situation. There are a lot of patients waiting in the emergency room, and the nurse will input the number of patients that are waiting. So let's say in the current situation, I'm going to use the insert number of patients. Yeah, so, and this is for example 3. Yeah, so the number of patients successfully inserted.
Right, I'll explain the second progress. After we insert the number of patients, we'll move on to insert the details of the patient. So after we select the second operation, here will be the details of the patient are inserted into the program by promoting the user to input the information about each patient. So here we'll start to write down number 2. So as you can see, the code first asks the user to input the name of the patient using these lines. So the user could be the nurse or the doctor from the emergency department. So let's say here John or any names, and here next they could ask to input the age of the patient, let's say 18, and then we'll write down the code ask to input the issue that the patient is facing. So let's say here heart issue, and then finally we will insert the second patient and the third patient the same way. After that, the code will determine the levels of injuries based on their age and the issues. So that's it for my part. I'll pass this to my colleague.
Okay, so these are the details for patient 2. The name of the patient is Iftikhar. His age is 23 and his issue is shallow throat. Shallow wound, sorry. Okay. Right, and this is the details of patient 3 are the name of the patient is Jordan. His age is 89 and his issue is heart issue.
Now I will show what happens when I view the waiting list. Till now my team members have inserted the number of patients and inserted the details of each of these patients. Now when I enter 3, the waiting list is then printed. In the waiting list, as we can see, here is the queue number, here is the patient's name, the patient's age, patient's issue of visit, and the patient's level of injury. Here as we can see, the lower the level of injury number, the higher the patient's number, queue number. So this patient Jordan will get to see the doctor first. So how this program basically relates, or how this program uses the priority scheduling. In priority scheduling, the processes with a lower number of priority has a high priority and will get the CPU allocation first. In this program, the patient is the process, and each patient's priority number is determined by age and issue of visit, and the patient with the lower level of injury number will get to see the doctor first. Basically, will get the CPU allocation first. So as we can see that this is the waiting list, and this waiting list will be seen by the doctor, and this waiting list will also be seen by the customer who is waiting, who are waiting in the waiting area. So Jordan, whose age is 89 and he has a heart issue, will visit the doctor first. Iftikhar, who also has a John, who also has a heart issue, will see the doctor second because he has a lower level of injury because of his age, and then Iftikhar will see the doctor at third because his level of injury is 5. He has a higher number for level of injury, which means his priority is low. That's it for the emergency room management system program, and then we can just exit the system. This is the program code for program 2, which is the coffee order management system. In this system, basically we have shown how non-preemptive shortest job first algorithm can be applied in a coffee order management system. This program is made in C++. It uses procedural programming and object-oriented programming. So we have two classes, which first we have the order class, which has private members such as the customer name, customer type, table number, coffee making time. In the public section we have the order constructor. We have the getters, which gets the customer name, coffee type, table number, and coffee making time. Setters are responsible for setting the customer name, coffee type, table number, and coffee making time. We have another class called the coffee. In this class we have two data members, coffee type and coffee making time. We have a constructor, we have getters. This getter basically gets the coffee type, and this getter basically gets the coffee making time. We have two setters. This setter is responsible for setting the coffee type, and this setter is responsible for setting the coffee making time. Then we have the read data method. Basically this method reads data from the database. We have the database text file, and in the database text file we have the coffee type and the coffee making time for each type of coffee. In the main menu, in the main CPP file, we have the main functions and some other functions. Basically this function is responsible for showing the menu to the user, and here the users are the barista and the customers. Then we have a bubble sort function. This function basically arranges the orders according to the in ascending order according to the coffee making time. Basically a coffee with a longer coffee making time will be at the bottom of the list, and the coffee with the shorter coffee making time will be at the top of the list. This is the main menu. Here in the main menu, if the choice is 1, which means this, insert the number of customers to serve. The waitress enters the number of order, and the number of order is successfully taken, and then a while loop is run. A while loop starts running. Basically this while loop runs for the number of orders that the waitress enters. So if the waitress enters 3, then this while loop will run 3 times, and this while loop will run 3 times, and this while loop will take the orders of each of the customers. So the first first the customer name will be taken, then the customer's coffee type will be taken, and the customer's table number will be taken. And then these orders, after taking this data, we will use setters, and we set the values, and after that we use bubble sort to arrange these orders in ascending order. And if the user enters 3, which means show order list, the order list will be shown. In the order list, the customer's name, the customer's coffee type, the customer's table number, and the customer's coffee making time will be shown. This order list will be shown to the barista and the customer. Basically, the customer will know when his order will arrive, and the barista will know when which orders to make first. So that's it for the program number 2, which is the coffee order management system. Now we will show how this program actually works.
So this is the menu for coffee order management system. Here, the coffee represents the processes. The processes need to be scheduled in a queue to be made. So alright. So let's say we are entering the number of customers to serve. Alright, say 1. And the number of orders. So when the waiter or waitress is taking the orders, they will record it on the paper, and then afterwards they will input the number of order into the system. So for example, let's say 3. Alright, so number of orders successfully inserted. And so let's say the waiter or waitress is going to insert the customer details.
After moving on from the inserting the number of customers, then we'll directly move on to the next options, which will be the inserting of the customer information or details. The option will allow the user to input the details of the customers placing on order. So let's insert it now. Number 2. So here we'll insert the customer name and which type of coffee. Say black coffee. And the table number, let's say table number. Okay. So like this way, after we insert the name and the type of coffee and the table number, the details are sorted on, let's say, in an array of order the object. So the coffee making time for each order is determined by based on the type of coffee ordered, and retrieve from a separate array of the copy object. So this is my part. I'll pass it to my colleague to continue.
So these are the details of order number 2. The name of the customer is if the car, and the coffee type is espresso. So, and the customer's table number is 34. And order number 3 details are, and the name of the customer is John, and the coffee type is mocha, and the table number is 55. Okay.
Now I will show what happens when I input number 3 and show the order list to the customers and to the barista. Till now my team members have inputted the number of customers to serve, and my team members have inputted the customer details for each of the customers to serve. So when I input 3, as we can see, the order list is printed. In the order list, the order number is printed, the name of each of the customer is printed, the coffee type of each of the customer is printed, the table number is printed, and the coffee making time is printed. The barista will see this list and make the coffee according to this number. So the barista will make this coffee first, then this coffee, then this coffee. And also in the waiting area of the cafe, the customers will be able to see whose coffee will come first. The order list is made based on the coffee making time here. So in this coffee making time, as we can see that black coffee, it has coffee making time 1, espresso has coffee making time 3, and mocha has coffee making time 5. So the coffee with the least coffee making time will be made first. The coffee with the most coffee making time will be made at last. This system uses the non-preemptive shortest job first algorithm. In non-preemptive shortest job first algorithm, the processes with the most burst time will get the CPU allocation at last, and the processes with the least burst time will get the CPU allocation first. Here the orders represent the processes, and the coffee making time represent the burst time. So the coffee making time is the burst time of each of the order, each of the coffee basically.
Right, we come to the end of our project. So in conclusion, what we have learned. We all learned a lot from this project, as we got hands-on experience implementing scheduling algorithms in real-life programs. Through this project, we learned about the non-preemptive priority scheduling and non-preemptive short job first scheduling, and how they can be used to manage and allocate resources in efficient manners. So additionally, we learn how to create a real-life program that can be used by real users, taken into consideration by various requirements and constraints. This project helped us understand the importance of efficient scheduling algorithm in real life application, and how they can greatly improve the overall performance and user experience. So overall, we thoroughly enjoyed working on this project, and we are proud of what we have achieved so far. This project was a great learning experience and has helped us further enhance our programming and problem-solving skills.
That will be the end of our project presentation video. Thank you for listening to us, and goodbye.